Project Evaluation Review Technique or PERT. That we discussed at the start of this particular topic also, like in certain projects like research and development, new product introductions, it is very difficult to estimate the time of various activities. So PERT is very helpful because in CPM we have seen that we have a very accurate, very deterministic time estimates, and we were finding out the critical paths in that particular cases. But in this sort of projects, it is very difficult to estimate that time. So PERT is used in this sort of projects with a probabilistic method using 3 time estimates for an activity rather than a single estimate. So we define 3 different types of time estimates here. The first one is optimistic time. This is the shortest time taken to complete the activity. It means that if everything goes well, then there is more chance of completing the activity within this time. The other one next is the most likely time, and this is the normal time taken to complete an activity. So if the activity were frequently repeated under the same condition, then this is the time which will be within which that the project will be around which the project will be completed most of the time. And pessimistic time, it is the longest time that an activity would take to complete. So this is the worst time estimate an activity would take if unexpected conditions arises or unexpected problems are faced in that particular project. So probabilistic activity times, like we talked about that there are 3 different times: most likely, optimistic, and pessimistic. So given these 3 types of times, we can estimate the mean or we can find out the mean and variance of this sort of times. So we find the variance of this time is b minus a, where b is the pessimistic time and a is the optimistic time, divided by 6. And whereas a mean time t equals to a plus 4 into the most likely time. A is the optimistic time, so optimistic time plus 4 into the most likely time plus the pessimistic time divided by 6. So this will give us the mean time, and this will give a variance of that mean time. So let us see it with an example. So say an example has been given to us. So like in this case, activity 1, 2 denoted by A has TA, which is 4, T optimistic, which is 4, T most of the time, so T most, Tm is 6, and T pessimistic is 8. So this is TA and TB, or TO and TP also be represented. So similarly for activity 1, 3, we have 2, 3, 10 and so on. So if we draw a diagram for this, so let us first try to find out a time for this activity, and then the variance. So if we since we have T0, Tm and Tp, so we can find out a mean time. So mean time, so this mean time will be, so this entry is basically 4 plus 4m, so 4 into 6 plus 8 divided by 6. So now you can compute. So it's basically 4, 6, 24, 28, 36 by 6. So 36 by 6 or 6 in this case. So similarly for others you can compute. And similarly you can find out the variance. So variance is basically b minus a, formula is here, b minus a by 6 whole square. So this variance can be computed as 6 minus 4 by 6 and this whole square. So if you compute it, it is 1 by 3 whole square. I hope so I'm correct. Sorry, it's not 6, it is 8. So this is 2 by 3. 2 by 3 whole square. So this can also be written as 4 by 9. 4 by 9 and if you convert it in decimal, so you will get 0.4444 and so on for all others. Now you have a single estimate, so this time can be taken as a single time estimate for this particular project, and we can apply a CPM sort of technique. So if we apply if we construct the network diagram, so we have activity 1 2 1 3 1 4 and so on. So 1 2 1 3 1 4 and then from I think 2 4 2 3. So if we make a diagram, we can get something like this. And now this time, so this time as I told can be taken as a single time estimate, and we can apply a CPM sort of technique, so we can find out the earliest start and the latest finish time. So in this case it is shown here in double square. So this is 0 0, this is 6 7, this is 14 14, 12 8, 4 2. And if you do an analysis, you will find out that this path is basically the critical path, because the slack time or float will be 0. So I will request all of you to work on this particular project, work on this example, just like in a CPM example with this time estimate, and you will get this time. Now once you have this, then the questions can be, in this particular case, in case of PERT, the questions can be asked as, what is the probability of completing the project within 19 days? Because if in this analysis we have found, what we have find out is the project duration can be 9 plus 5, 14 plus 8, 22. So this project, according to this this time estimate, so mean time, the mean time of completing this project is 22 days, say. Now the questions can be, what is the probability of completing this project within 19 days? So we can find out a Z0, so which is, the formula is TS minus TE. So TS is the time which is given here, and TE is the estimated time. So in this case 22 is the time which we estimated by CPM technique using the mean time, and 19 is the time given here, and then the sigma in the critical path. So sigma in the critical path, so 1 4, if you see 1 4 is 2.77, so this is the sigma, and then 0.444 and 1.777. So these three sigma values are taken and square root of that. So if we do that, we'll get this value. Now with this value, z of this value, basically since this is a negative value, so this is situation can be represented graphically in this way. So our mean time to complete this project is 20 days. Now we are trying to find out a probability that this work can be completed in 19 days. So say 19 comes here. So we need to find out this shaded area. What is the probability of this shaded area? So the probability up to this point, so probability of this whole area, we know that this whole probability is 0.5. So up to this, the probability is 0.5. Then we can find out what is the probability of this area. So the probability of this area from mean is, we can estimate it from that table. So if we look into a normal table, we can find out, since this is negative, so we are going in this way and we are removing now the negative side. So we are doing 0.5 minus this value. So 0.5 minus, and z value of this is 0.4099. So 0.5 minus 0.4099, so it will give you 0.0901. That means this project will be completed in 19 days. So this probability is only 9%. You can say the total area in this particular case is 0.9. So this area is only 0.9. So we can say that this project will be completed within 19 days. It just have a probability value of 0.09, or there is a 9% chance if we represent it in terms of percentage. So there is a 9% chance that this project will be completed within 19 days. Similarly, if we say another question like, what is the probability that this project will be completed in 24 days? So in that case, similarly we can compute. So if we compute in this way, the probability or the z value we'll get is this one. And now So this will be addition, not minus. So this will be plus because this diagram will be something like this. So we are moving on this side. So this 0.5 value, so this whole area is 0.5 plus this area. So this area probability is 0.3133. And so if we add these two, so we'll get a probability value of 0.8133. So or in terms of percentage, we can say that this project will be completed in 24 days with a possibility of 81%. So this will be completed in 24 days, has a possibility of 81%. So this is what this is where I will stop today. So there is given any PERT net in a nutshell. If we just say what has to be done in case of a PERT network. So in a case of a PERT, you will be given 3 time estimates. So from that 3 time estimate, you can compute a mean time and a variance of those time. So once you have that mean time, and the formula for mean time is TO plus 4TM plus TP by 6. And in case of sigma square, it is TP minus TO divided by 6 whole square. So once you have all these things, you can consider this time. So T mean is to be the time which is normally taken, and now we can use a CPM sort of technique to to find out the critical paths. And this time, when in a mean time of project completion, you will get. So in this case, that mean time was 22. Now, once you have found this, then the questions can be, what is the probability that this project can be achieved within 22 days? So it can be achieved within, it can be finished within 20 days, it can be finished in say 30 days and so on. So that sort of questions we can compute using the normal table and by using this sort of techniques. So for today we'll stop here.